One of the most important things on your computer systems, and it doesn't really matter if it's Linux or if it's Windows, whenever you're trying to get speed out of your machine, or if you really want to negatively impact the performance of your machine, always choose one of these at the bottom of the pyramid in order to use that as your base file system. So as you can see, an NVMe SSD will gain somewhere in the amount of speed from 2 microseconds to 4.3 microseconds. So it's quite a bit of time as far as a computer is concerned. So today we're going to look at 5 different file systems for Linux. And those are going to be Bcache which is a new file system with the latest 6.7 kernel. Btrfs is another significant file system that we use. Also, ext4 has been around quite a while. There's also F2FS, that is a flash-friendly file system that was developed by Samsung. XFS, it's a file system that was built for high performance workloads by Silicon Graphics. So are we going to look at Riser FS? No. So the reason for that is the Riser FS team that was developing it is pretty much idle. And the Linux kernel folks have said that if things don't change, sometime in 2025, they will deprecate Riser FS. ZFS, I wanted to test. I tried to get it to work on 6.7.2. It failed to install. There's a compile error when it's building the modules. I am going to test this today on hardware. This is the latest machine I have. It has 32 gig of memory. It is a Core Ultra 7 155H that makes it. There's 2 drives that I replaced the one that was OEM. It's a little on the slow side. So I replaced it with a Western Digital NVMe. This is a SN850X. It's a 2 terabyte drive. It's PCIe 4. And I have 2 of them in there. One of them is the boot drive, and the other one is the one I'll be testing all these file systems with today. The OS I'm running is the latest build from Endeavor OS. It's an Arch-based distribution. It's running KDE, and it also has a 6.7.2 kernel. I did try to I normally like to run the Phoronix test suite. It just makes it more consistent and when comparing the other benchmarks that I do. However, there's a bug in the current build out for the PTS file, which does the file IO tests. So today I'll be going back to IO Zone 3 and running the benchmarks with it. IO Zone 3 has a number of tests that it can perform. This particular version is 6.7, of course, for the kernel, and in the previous release, 6.6, the Linux scheduler was switched out. They're moving to EEVDF, which it's supposed to be more fair. And there's also the Intel cluster. It's for hybrid processors like the one I have here, where you have hybrid means you have a combination of performance cores and efficiency cores. So the first one is the initial write. That one is just a simple measurement to write out a sequential file on a blank drive. So we got Bcache, Btrfs, ext4, then F2FS, and then finally XFS at the bottom. And then we have the 5 worker loads for each, and that goes in different shades of blue. But as you can see from this, one of the things that I've noticed is Btrfs has improved quite a bit from when I first started looking at this 3 years ago, I think. And it was not handling things very well. But as you can see, the idea is as you add users, there should be a pretty smooth ramp up. You probably will see a jump from one to the next in performance. And then at some point, it's not going to be so much anymore. And that means that you're approaching channel speed, so your drive can't go any faster, or you have something else that might be limiting the performance of the drive, something that could be blocking it. If it backs off, like you can see ext4 doing there between right after it reaches 3, when it starts to do 4 and 5, that's actually slowing down, that means that there is something interfering with it. And the something that's interfering with it is I/O wait. So what's happening is the system's going, whoa, whoa, this is taking, you got too many writes here. And so I'm queuing them up, and I'll handle them as quickly as I can, but you're throwing way more at me than I can handle. So yeah, the system is just like, you got to slow things down a little bit. F2FS, it scales up to 2 worker loads and then it dies. That's about the best way I can explain it. It just rolls over and dies. Now that I didn't see that kind of behavior before, so I don't know if they just haven't adjusted it yet to this new scheduler, or I just don't know. I really don't know. XFS at the bottom does pretty well. It ramps up smoothly till about 3. It's doing about the same thing as ext4 is. You notice that on 4 workers, it kind of backs off and then it comes up again. Btrfs and bcachefs are both ramping up pretty smoothly. And then Btrfs at between the 4 and 5, it flatlines. And again, that is I/O wait times that are building up in the system. This is the next one is just a sequential read. So we built the file and now we're going to turn around and read it. You'll notice that bcachefs is smooth. I mean, the transition from 1 worker up to 5 is pretty linear. And the same with Btrfs. It's nice. It's a nice progression. And the performance is smooth on both of those. It's doing exactly what it should be. ext4 is doing a lot better job as far as throughput with this workload. F2FS does the same thing, gets out to 2 worker loads and then it dies. Then you have XFS that's doing the same thing. When it's going between 4 and 5, it looks like it's probably approaching the channel limit. That's as fast as the drive can go. Rereads. Rereads measures the performance of reading a file that was recently read. So it's reading the file, then it's backing up, and it's reading it again. Basically how cache files work. So we have bcache as you would expect with this kind of workload, it does pretty well. Btrfs does a better job at the higher end, but you'll notice that bcachefs is actually slightly faster until it gets out to the 5th worker load. ext4 does smooth out to 4, and then there's a slight bump to 5. Again, could be channel speed, because if you look at XFS at the bottom, it's doing about the same thing. F2FS is, it's just not doing the job. Let's just put it that way. FRead, these are stream reads. So in Linux, most of the time, most of your utilities are written using FRead and FWrite. And so here's our results. As you can see, the system performance is a lot better here. You'll notice that things kind of even out as you look down through bcache and you look at Btrfs and you look at ext4. Now, ext4 is not performing as well as Btrfs, and this happened in last year as well. That ext did not keep up with the workload in this type of workload as well as Btrfs did. But bcache is showing, so for the preponderance of workloads, Btrfs used to have a problem with, some of the lower workloads, but I'm not seeing that. So that's been improved. In other words, if you had 1 or 2 users on the system, the performance wasn't as good as the rest of them were at those same workloads. But I'm not seeing that now. So they've been working on it, and it shows. F2FS does okay here as well. It seems to handle that kind of workload all right. XFS, of course, is kind of this is what Silicon Graphics designed it to do. I mean, that was the preponderance of the workloads that they had. So yeah, that's what it does well. FWrite, same thing. It's streaming the opposite way. This time, the memory is pushing data from the application just as fast as it can, and the drive is trying to pick it up and write it out as quickly as it can. So this is usually where we have problems with copy on write architectures, and we still do. And the reason for that is every write that you do has to first copy the area that changed. So copy on write is not going to do as well as the more traditional file systems. And it looks like F2FS, I never really thought of it as copy on write, but it looks like it has kind of similar characteristics to Bcache and Btrfs. ext4, of course, is not copy on write. XFS, I think this is an area where we saw this kind of a behavior before, where it was able to handle 3, and then when it got to 4 and 5 workloads, it kind of backs off. So mixed workload, that is reading and writing a file in place. And so, yeah, that typically would be a system that is updating a structured file, one that had records in it, for example. Those type of workloads, Bcache-FS doing well. In fact, better, on the single workload than Btrfs does. Btrfs takes a little while to ramp up. It takes a number of users to really have it reach its peak performance. But once you get out to the heavier workloads, and this I did not see last year, so there have been definite some work done with that driver to make it more responsive, and that's good to see. ext4 is still faster than both of those in the higher workloads, and in fact in the lower workloads as well. The XFS, yeah, it's fine. It's doing similar type of work. PReads. PReads is you're reading a part of the file and then you're going to jump to another part of the file to read another part of it. Typically, those would be like zip files or graphics files like that have header or metadata in the front. And so you'll read that off and then you'll jump to the portion where the actual image begins and start to bring that into memory so that you can display it. So as you can see, they all do, they're all performing very well. I wouldn't say that that performance is terrible. It isn't. Of course, EXT and XFS have been around a lot longer. They're more streamlined to these workloads, so they're going to be a little faster. I'm not going to talk about F2FS anymore, so I don't want to laugh at it. It's not funny. It's just that it probably needs a little tweaking. And then let's look at PReads, which is a similar type of architecture here. Now, in this case, Btrfs does really good. It's smooth. It's not, it's not clumping up and then falling back as the workload builds. It's stretching and able to handle the workloads as they come. Now, I think it's getting close to the dry performance or and I say that because all of them kind of hit that window and stop. So, but yeah, it does quite well there. And I did not see that before last year. That's new. Random read is, it's type of performance that you would see with files that are typically read with a key. In other words, there's some kind of index that has a pointer to a location in the file that says this is the beginning of a structured record. And so you would want to jump here and read off that data without having to seek through the entire file to find it. So that's what it does. Now, of course, in NVMe drives, you're basically accessing it directly. You're not waiting for the platter to spin around or the head to reach the location on the drive. So yeah, and then you have the performance here. Again, it's all doing well. Yeah, I said I wasn't going to talk about F2FS, but as far as the 4 remaining ones, they're all doing pretty well. Again, ext4 and XFS are better because they've been around longer. They've been tweaked and prodded, but clearly Btrfs and Bcache both there's been performance work here done on both of those. So yeah, to get it up to this level of performance. Random writes, same kind of thing as the random read, except this time you're creating those structured records on disk, right? This time Bcache falls, it gets locked, or it gets wrapped around the copy on write problem where it starts to fire. You can see it clearly firing off copy memory block sys requests, which are stacking up, and then we're having a problem because we get IO waits. We're waiting for all those sys requests to clear before we can actually start the IO. Btrfs is obviously has done some work here to try to optimize their performance better, because last year when I did this, it was bad. Yeah, it was not good. ext4, it looks like it's pushing right up against the drive performance limit, and same with XFS. Although XFS is dropping off a little bit on 5 on the 5th one. Rewrite is it's writing a file that already exists. So in other words, if I've got an update I've got to do, maybe I'm updating the metadata, the date and time in a Word document or something, and yeah, that would be the type of thing you would see here, is that it would be updating enough information about either the size or whatever. Bcache, it's not performing as well and with that kind of a workload as Btrfs has kind of a weird behavior here at 4. And for some reason, when I was running this, the IO wait time on the 4th workload went through the roof. It actually hit like 6%, which threw the system into the red, meaning that it was backed up. It was actually causing delay. When it got to 5, though, it cleared. So that's kind of weird. ext4 runs out until it hits looks like the maximum performance, and XFS kind of dies back after the 2nd workload. So, and then builds back up again slowly. Reverse reads, this is something that you'll see in compilers when they are parsing. You'll see that sometimes they'll parse the file backwards. Reverse logic sometimes is more efficient than forward logic. So yeah, when you're looking for a search. The Bcachefs and Btrfs are they're almost neck and neck. Bcache has a little bit higher performance in the lower tiers, and then but they're about the same. They're really close at 5. So they're both doing pretty well, really. ext4, yeah, it just does what it does. It does what it always does. It just works. XFS, same thing. It just works. Not quite as well as the ext4, but it just works. Strided reads. So if you're running a database, this would be very common. Stride reads are, I am reading part of the file and then I'm jumping way in. Now in NVMe devices, that's gonna create kind of irrelevant workloads, because you don't have to wait for the platter to spin around. But if you're using rotational drives, yeah, stride reads and stride writes can be devastating to your performance, because you're waiting on Seq. You're waiting on the Seq to complete. But in NVMe, as you can see, it's all pretty smooth. Yeah, it just ramps up, and they're all doing that. Btrfs and Bcachefs doing great. EXT and XFS doing a little bit better. Overall, which one is the best? That's the question. So we're going to use the Geo-Mean to determine that. That's an Bcachefs has had some areas where it was slower, and Btrfs did too. So, but hey, Btrfs is really, I think it's improved quite a lot, to be honest about it. ext4 and XFS, yeah, they're kind of pick whichever one you prefer. So let's talk about some of the problems I have had with Bcachefs. So I had mentioned in the first video I did on Bcachefs that I was experiencing a problem where I would create the file using their utility, and it would format and it would mount and everything was good. I could unmount it and mount it back in the same overall system session. In other words, I hadn't rebooted the machine, and that worked fine. But if I restarted the machine for any reason with the drive mounted, I come back up I mount the drive, and it gives me an error that the super block is corrupted, that it can't read it, go away. This is not what I expect it to be. I have tested this on a VM. It has the same problem. I have tested this on the Intel machine, same problem. I have tested this on an ARM machine, same problem. I want to thank my Patreons and also my channel members for supporting this today. I sure do appreciate you guys very much. Anyway, that's all I had for today. Please like and subscribe, and please share this out with your friends. I sure do appreciate you watching today, and hope to see you again in the next one. Bye for now.